Yeah. Second. 11. 13. Wow. Okay. Don't know how to count them. Yes, I mark. You're gonna write this one. Then you're gonna work on this. You're gonna read this and do it. So, as I mark this, come on. This one, and go to number one. Then we go back to our exam one. This one is your first one. Then there's the second one. Second one is this one. The third one is this. Right? This one, this one we start with because it's where we are at now. This one, this one, this one, revision pack. Eh? This one. Put it here. Now we're here. Let's start. Mistake number one. No? Mistake number one is that I don't know. Mara, this one I got it was the first attempt. I got. Right? So it was this question. Okay. Question 4. Right? So paper 2 maths, analytical geometry. Yeah, here. 2013 September Northwest question. So this one you nailed it, but I think you fumbled the back here. Mistake number one I saw was this. So for instance, this one you got it right. I don't know. Determine the coordinates of V, right? You got it because you use this and this. How much? 3 marks, no? Okay? And because this is fine, right? Then more, the full distance formula is fine. Substitution is fine, but like here, you made a mistake. What do you see it now? What's the mistake? Sign, okay? So more supposed to be 1 squared plus 5 squared, okay? Supposed to be how much? 25 plus 6, square root of 26.
Square root of 26.
Ne? Right, let's check it. I think it's this one. Okay. Yeah, this one you gotta write this one or get this one. Fine, right? So this one I'll go with this or something. So more homes you get 4 money. 1, 2, 3, 4. Then this one you get this substitution. Then how much? 3. Then minus 1. for the quadrant. Is it cast? Eh? How does it start? Is it all right? C then S like this, no? So what you got? So what we got here is come. You have a minus sign, right? So if you have a minus sign, you take it here. You have a minus sign, right? This will give you what? Check it. Hello, Nabi and the guys. So 10 is positive only on the third quadrant, right? If it's positive only on the third quadrant, and then you get a negative 60, 71, then what do you do? Yes. Get here, it's 90, then plus 180, then 270, then 360. Then you just say 180 plus, because here you want to get the positive one, because here they're all positive, negative, negative, positive. It's time. So you got the negative one, meaning you got this minus 60, 71, I mean it's here, plus 180. Then you will get the positive shyness, right? I want to just use the plus for the cast, then minus for the angle, which is supposed to be 50 before. But this one is not the final one. This is not the final answer. You see, I don't know if you can see here. You see, before you get to the final answer, you have maybe 3 decimals so that you don't lose that at the end. Then final, therefore it's how much? $108.4, right? How much did they get? 4. So it's the rounding of error. Angle reference, you use this one. It's for the angle ref, right? This one. Which side, positive, and all that, I don't know. Then you have your answer. This one is the 1 mark that you lost, right? Only. So right here. So far, mistake, sign mistake. Angle reduction, I think it's reduction or something. It's called reduction. Right? Then 4.4. They say if PU is parallel to QT, determine the equation of PU. Right? So now, what did you use here? You use P, which one? This one. Minus 2 and minus 3. And then you found you have the gradient. What did you get it? You said MPU is equals to MQR. You use this one. MQR is this one, right? QR, which is negative 3. Then you use this gradient, and which point? This P. So the gradient of this and the gradient of this will be the same. Then you only use the P that is correct. Is substitution. Then the final answer is this. From C, yeah, minus 3. Right? Did I give you all the answers? And minus 3 straight line input substitution. Done. Right? Answer. Substitution. That's it, right? Which is 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? PT. Determine the equation of a straight line PT. PT. Where's P and T? Okay, this way. So already we can see. Oh, what did you do?
Is it a PT?
Mm-hmm.
A perpendicular to QR.
Okay, by the sign that you see, right? Okay, and then
W is
equation of a gradient where two where two lines are perpendicular, then we have a product of -1. Then you did that, you got this. What else? Yes, yes, you got it to this. M2 is equals to 1/3, which is positive, right? It's going this way. Then what else? You substitute this P going this way, right? That's the point. Né? You will get C minus this, right? Then your total equation will be S minus 3. If you did on the competition, right? This makes sense. I don't know about this. If you did all right, then it's supposed to be this, supposed to be right. Why? Okay. Let's see. Yes, you got it right. Then let's see how they marked your product line, right? Which is 1 mark, this 1 mark, correct formula, then substitution here, then simplification. 1, 2, 3. Simplification is what this, right? Writing in standard form. We have everything in here. 1/3 minus this. What's left? Maybe here. Operations. 1, 2, 3, 4, 5. That's it, right? You just didn't use their method, which is still the same because it's gradients. They just use the original. Then here, determine the equation of a straight line PT. I calculate the y-intercept of PT. Y-intercept, which is this one, right? Then you have a straight line. Let x equals to 0. Okay. Substitution. Right answer. Alright, is that 1 marks? Ha! Maybe it's because you have this already at the top. Right? That's the y-intercept. Then question 5. But they were not that hard, eh? A circle center A cuts the negative axis. Okay, this one. At B. And D is at here. Calculate the length of the radius of the circle. So you need this. Okay? So what did you do? You took Q and A. Then calculate the distance between, right? What did you get? 5. What did they get? 5. It's the formula, the substitution, and the formula they don't mark. Substitution answers. Yeah. Now there's a half marks. Alright. 5.2 and show that the equation of a circle is this. So they give you the equation of a circle. They just want you to prove. How did you prove? By squaring the factors, or what did you do here? Pythagorean theorem. You have your r, you have your. This is the same as distance formula. You just use this and squared everything and then went up. That's how it works. Alright? Because this is this and this is the same, right? Or diag. And then, yeah, you square both sides. Then this one. Then, correct. Nice. How do you mark? They substitute this side. The final one. Where is it? This one. Oh, this two. Or half. Or for the square. If you do. Oh, this one is just simplifications. Yeah. Then 3. Just like one of the there's what they are clear to you. So that's good. 5.3 calculate the coordinates of B. This one is the x-intercept. Right? What did you do? Well, now what did you do? You said distance formula. You have your 5. Then here you have 2 unknowns. How did you conclude? Like from the factors that you had. Yeah? You mean here from the graph? How did that happen then? Or like from here to like you assume that this thing they are aligned. Did they give you the properties like that? 5.3 calculate the coordinates of B. 4 marks. At B, y is equals to naught, right? This one. Then you put that naught there. What do you get from this one? If you put y naught, y equals 0, 0, then you have x squared minus 4x minus 12. Right? Which is this. Then you solve in the 2. It was 4 jets. Okay, minus 6, you know? At B. X. So that we have this solution at B. Therefore, what's the other part? That other part will then be 0. This one that we let. Go on. He's not into your father. Normal. Okay, get la motlhalosetsa re sa theoetswenyana to. Buddy. Sharp. Ma. Mamolo a re phone ile a itsene. O tla mo check. Sharp, are ya voicemail right through phone mo fileng yona, sharp. That's 11, 20 try. I only knew this picture. I thought, but again, 11, can we do 50?
Maybe get it like 11.
11. My girlfriend the birthday I get 11. The day before yesterday. The day before yesterday. March. That's what I 13. Friday the 13th.
KK guy.
I didn't find this
Sure.
line.
My dad.
My charger. Yeah. So okay, sure. This one. No, let's not. We should look at the memo after we analyze the question. Determine the equation of the tangent of the egg. This one I saw it. Oh my god. Why did you mess up this? Determine the equation of the tangent to the second at the point Q. At the point Q. I get determine the tangent. The equation of the tangent. What is the equation of the tangent? This equation, right? Not this. Right? When you did this. You did this. The gradient is negative. This one, the gradient is positive. That was your only mistake. Right. How many mistakes do we have? We only learn by mistakes. 3. And there's a lot. Again, we have other ones from previous. It needs to be a list. You need to be obsessed with writing that list of mistakes. Once we know why. The things that you're gonna write in are the things that you are always gonna be trying to avoid at all costs. Once whenever you see them, it's like, hey! Once red flags. Sharp. Then this one, what do you think the mistake was here? 5.3. Or what you said, you just looked at the thing and then that was just the silly mistake. I don't think how would I categorize this? Our x-intercept, it's just forgetting, just pure forgetting, or like you're supposed to see like if it's talking about coordinates, let y, let x. That was the purpose of it. I don't know.
Yeah.
Then Gamo. Okay, look at the gradient. I'm sorry, why it's a gradient and it's changing whatever. So this one you're supposed to have this. Or you actually I think you have it somewhere. Or you don't. Oh, you don't. You don't, because it's all about this too, or even this. Are they collinear? They just they said something about the other button. So this one and this one, ne? Straight line. Then after you supposed to say that thing how m1 multiplied by m1 m2 minus 1. Then you get that what is equals to positive 3 over 4. Needs to be positive. Then from being positive, you put it here. This one is going to be changing because, if you have a positive one here, then now what's left is positive, then 6 minus something. 6 plus something, not 6 minus something. I get it. I get this one. If it's positive, then you have a negative. This one is going to be negative. Then when you put it that other side is going to be positive. So mean it's going to be 6 plus 3 over 4. Yeah. Over 4 times 2 again. Which is 15 over 2. So we have it. Nope. We have this one 4 over 3. It means why is this 3 over 4. Something each. Let's do it. We're trying to correct the things that are not correct. Let's do it. Y1. Kiwan, did you copy the coordinates correctly? You sure? Okay. Y2 6 minus 3, right? Perfect. Then this one, it's minus this minus this. This is positive 3 at the top. This is positive 4 at the top. Why? You think they made a mistake? The operation here. So it's here. The source is in here. The source is in the eating. What's MA multiplied by MQ equals to -1, right? MA is this one here, -3/4, right? Multiplied by MQ. It's gonna be an inverse, obviously. If this one you have MQ, then you divide this one. If you divide this 4 is gonna be at the top. It's gonna be positive. Then that's why we have (26 over) right? How much do we get? 26 over 3. Yes. Therefore, is equals to 4 over 3x plus 26. Right? Correct. So this one mistake was just the gradient. Looking at this slopes, different slopes. Right? Then I must mark this. I should be marking this, no? This one. Substitution. Equal and save flow. 5.5. Okay. Determine the value of P if D, A, and R are collinear. What is collinear? Collinear meaning they have the same gradient, right? M1, M2, M3, they're all the same. Because they're sitting at the same gradient, same straight line, right? So if that is like that, then you will say M from MA and MQ will not MQ. MA is the same as this one, MD. Then you will then say from the previous one you had this gradient before, right? Which is here I don't think you're going back to 4 over 3. 4 over 3 was just this one, the positive one. This one goes like this. It's sloping down, so it's supposed to be negative, right? Then how do you go about it? You have 3 points. This one you have X and Y here, X and Y here. You don't have, they say R, D, A, and R is supposed to be, it's somewhere here. One, it's somewhere here. If you can see the X coordinate is -3. So it's supposed to be from -2 to -3. Whatever. So it meaning they have the same whatever. So what is this gradient of A and D? Do you have it? You have it. Okay? What is this one? Which I don't believe.
We'll say it.
This one. Yeah, Mara like this thing on it's home. This C part. So what do you think we should do to get to the correct? Because it's 4 marks. How do we get to that? We need the thing, the gradient for this side, then that's it. Right? Which is, when are we really done? Wait, right there, it's not here. But we have this. It means now we have to get the full equation for this. Okay? And if we get the full equation, we get this, right? Your wrong answer for this question is the right answer for the next one. Hey? Hey, I think so. Because if that's the case, this is correct. Where's the name? It is correct. I don't see it, but it is correct. Wait. I think I got to feel it's on 5 point something equal. It's another page. Whatever. But like unless because it's gonna be 3 on the other side, come is gonna be x and y, then it's gonna end up making this be. Yeah. All right. Okay. You know how many marks? 4. So, make my guy substitution. Then the gradient formula you don't have. Like something like this, you're supposed to do this. Whatever. This xy minus this. But what can I do to collinear? I didn't say M, D, and M. Taylor, you must say, how do you get to this point? M, A, M, R. Right? Over 4 even. Right? This one, it's another mark for that. Then from here, you go and substitute. That's where you find your this one. 1, 2, 3. Then 4 will be this one. Yeah. 1, 2, 3, 4. Then what else? Question. Okay, this one is a different story. 1, 2, 3, 4. This one, if you let him. Ne? For detail money. The rest, you did not have another page again? Okay. No stress. Paper 2 done. Paper 2 done, especially on this one. But this one were easy questions. I think they were easy. On this one, the only difficult one was just this. But just you having to look at the gradients. Looking this way, that's it. Then come on. It was all about this one. Question, 5 marks, right? These are beginner questions. What do you want? These are beginner questions, all of them. But they were good for your revision. Let's get to this. Question 9, I think I'm going to feel more. So what now? They have this. They give you the equation. They say 9.1. They calculate the x coordinates of the turning point at F. How do you get that in derivation equal to 0? How did you get it? Because maybe it doesn't equate to 0. Why? Let's see how they mark for you when you are Levitzing. When you have limits, let's see how they mark. They have this f of x 16. Then they have f of x equals to 0, or so you're gonna have these two. Then this one you're supposed to say sub in sub inequation. Okay. At the x values you have factors you do have or factors you don't have, because factors are in this form. One factors. This one is x values, is fine, correct. This one is standard form, correct. F of this is important because we are showing them at the top of the integration. We have this, so we left with 1, 2, 3, 4, 5. Right? Wait, you skipped a lot. Because I want to see this as well to 0, which is the same as this. Or I want A or A, which is like, I don't know. So you're supposed to do this and then do this. Or after this, have that equation where like you substitute, or you'll have these factors of like 3x into 8. I don't know, yeah. 9.12. Calculate the x coordinates of the point at which f of x is a maximum. How? We said negative 2, but I don't think that's the right answer. You need to show. Eh? Or did you know how to attack it? How? Because I really like calculus. Oh, it's all sharp. So we never really have. Q's. More Q's. Right? 9.8. Point of inflection. You're showing where this f of x that you did at the top, you're showing its maximum. So you are having a local minimum and a local maximum at another global equation. So you have this one, which is your global. You have this one, which is your local. Then under this local, you have your point of inflection, where everything is stationary and the graph is changing shape, like this part. I get. So let me write it for you. Stop wasting time. F of x 0, right? Then you have this again. You will have 6x minus 2, right? And you will have x plus 2 minus 1. Yes. Then 9.2. 9.2, but I'm consider the graph of this. Determine the equation of the tangent to the graph of g at x minus this. So you just have to get the y first. Ne? Substitute this into y. What did you do? Oh, wait. I was gonna get I got its 4 marks. Let's see how it's done. I was gonna get the y, then have the 2 points from those 2 points, but why would I need them? Because I can get the gradient. I just need to manipulate this gradient because it's a tangent, right? It's like going or like touching or like once it's at that point. So how did you go about it? I think I need more practice. Oh, you even stated this. Gonna get one. So how did you go about it? You went here and then said this and then sub this and you got this. This might be your maximum value.
Gradient.
This is not a gradient, I don't think.
I get it first.
First derivative is the gradient. But now, you have the x value for it. So now it seems like you're having the x and the y, you see? Like this is the x, this is the y for that point. Now, I don't think we need a point. I don't know. Like, is this the original one? Yeah, like this is how I was thinking. You see, substituting that thing inside the maximum, the original equation, getting the y. Then I said, what would I do with that point? Because it's a point. I will maybe manipulate that point into getting an inverse of a tangent first. So I really want to you see, this is u, right? The gradient, right? They have two m10, then they have this one. So this is a point, this is a gradient. Oh, after having a point and a gradient, they do equation. After that equation, then do you inverse it or what? Because you don't, that's how it is. Because they gave you the x of minus y. They told you already what that's the equation of the tangent. Oh, now I get it. Cool stuff. So what do I mark? This one will only help you get the how would you use that point to get that equation, because you have the gradient. If you have the gradient from you here, ne, then you will need another point. So if you started here, when after this you will go and need another point so that you can have this y mx plus c. I get you have this now with the whatever that you have, right?
Point e ke grille ke y, ke re tsena mo. Point e ke grille. It's a wink e grille.
Yeah, I gotta know now this thing. You only did that, which is this. You said that's the gradient, because you substituted here even on the second derivative, not on the first. Now I was talking about the first, or like the way it is like more. The here determine the equation of the tangent g, or when I say g prime, g. So x is this. So I will take this and put it here. Get the y value and the x value, which is this.
Oh, so ke point ke not x ke grille y. Then
On a x,
yeah.
y. I get obviously y. That's the point. On the graph, which is affecting also what the tangent, right? So now when you get to going further onto the solution, let's see, you will have a point. I get come sub that minus one into what you'll get that 12. This 12 goes hand in hand with 1, which is x coordinate, and y of 12. See, then I said, how would I even use this point to get the gradient? Because in my head, I will need another set of x and y so that I can get the gradient. However, it's calculus. How can you do this? First derivative, right? Because you have a point now from the original equation. I can take the first derivative of the original equation, then get that minus 5 that you got there. This is now my m. This is now my point. I only need my c. How can I get my c? Then I substitute by 12. Now it's doable. So now you put your 12, you put your minus 1, then you get your c. Then after getting your c, you get your minus equation. That's the equation of the tangent. All right? 4 marks. Okay, what are you, right? What I finalize? 9.3 h of x for 3. Explain if it is possible to draw a tangent to the graph of h that has a negative gradient. Show all your calculations. Is it possible to draw a tangent to the graph of this? Let's see. What did you say? You already have this one. I get. Let's say now you have this one. Go into the next question. I get. Um, okay, so they're obsessed with this, the negative gradient, right? Then here, if you do it, you only have the positive, right? So this is going another way. This is a straight line going this way. We already know the properties of this. It's going this way and it's cutting at positive, at positive 7, right? Like so. Okay, okay. So it's like we have right. We have something like this, then we have something like this. Or here, I don't know, but it's minus 5x plus 7. Somewhere it cuts at 7. It's sloping at 5, right? So now they're trying to see if explain if it is possible to draw a tangent to the graph of h that has a negative gradient slope. I will firstly find the gradient. Right? It's a question. For which values of q will the line minus 5x plus q not insert the parabola? Eh?
Not intersect the parabola.
Or will not intersect the parabola. Yeah, this part that they am explaining. They want you to find it out before you can go to the next thing. Where will it not interfere with the parabola? For which values of q? Q, what is q? Y? 7, Then we need to see all the x values of this original. What are the x values?
Minus 8.
Minus 8, only 2. There are only 2, no? So they don't. Unless we know this one, ne? We find the x-intercept for this. You get me?
Yeah.
Yes. You we have this, we find the x-intercept, then we check, we verify from this. What is the x-intercept? X-intercept will be your x is equals to minus positive 5 over 7. Then this one is not 5 over 7. It's 8 over 3. We're gonna wanna look at decimals. It's 2.6, ne? Then 5 over 7. 0.7. No. I touch on it. Because they are x, Or is it? Let's see how this works out. Greater than 7. Because this one I got it's a quadratic, you take it down, it's a parabolic. This parabolic cuts here at 2 and what? 2 and minus 2.6, right? Then now they're saying f plus 7. So now it cuts at positive 7. And it's like this, right? Let me carry over more a so it's here somewhere. But this one I don't know where it is. It's that parabola here. Then you have the Cartesian. It cuts it at 0 and positive 7, which is the y-intercept. The x-intercept it's 0.7 positive. And y 0.
0.7 again, why?
0.7 x, I mean to say. It's x value like here. And it's positive, so meaning it's this side. Right? Hey legamo. And then our y is cutting here. 0, 7 and 3, and then we have x and 0 and y of 0, which is here. We have 2 points, so it's then that parabola is here. That parabola is here. Your g get to minus 2, whatever. Get q. Our q is greater than 7.
No, but equate in formula G, le, working straight line equation.
That's another method. This I'm here now. This one is another way of solving it. I like that much. But like they used it, the way you say, they equated what y's because more than get this one g. I get it's from here. I get or it's not even from here. Where does this come from? Oh, it's a second consider the graph of this. Oh yeah, it's another question. It's not this. It's not the same question. So sharp. Okay, we have these two graphs. Then what was the question? Because I'm kind of lost in there. For which values of q will the line y not intersect the will not. So if we have those two where it will not intersect at c that is greater than 7, not equal to. So let's see. C greater than 7 or q greater than 7. No, but depending on what you use, you usually use mx plus c. Okay? Then let's try like it.
Yeah.
It's 1.3. Let's see. 9.3 here. Okay. Then we do the very same thing again. Okay, look, I got that. Then no. Fuck. It's giving me problems. Which is weird. Whatever. Let's look. Becomes complex. Therefore, and I don't think you guys are using having complex numbers at your stage. I don't think so. But yeah, this one gets a lot of the application. You know it, application is very nice. You just do what you do, but like with the considerations of this maximas, like 1, 2, 3, you're just playing around from here to here. You just I'm gonna look at 4, 5, 6, 7, 8. 8 plus 11, 22. It's 30. Ne? Eh? It's 30. 11 plus 11, 22 plus 8. Ne? Yo, naga. 30 over 70. What's the correct? Just the thing. 17 plus 18 plus 20. Get on, naga. 335. 55. 32 over 55. Not bad. Not bad. But it's bad for the first one. I think Chawileng gets those mistakes. This one, it's a major one. And this one's it's your common one. And this one. So that's why maybe giving you that 10 minutes to review will help. But it seems like you are fast. You are too impatient yourself for your own process. And then also on being too careful, take Charles' time. And when you are fast, you do the right thing, but like, so I can do. What do you think after sir? What do you think? Because I've seen you doing this maybe 3 times. Okay, we'll ask ChatGPT then. Yeah. Okay. What's happening? Then here, we're here. Isn't perfect, another? Question 1 and 2. Almost. Three, 4. Then we'll go to 5 here. We should talk about it. It's been an hour deep. What that's it? Check or and look at this because I have the questions. When I get, can you give me question 3 and 12 while I change this? So I've checked you what I'm marking. Let's sugar fits. Or if I'm mama, that's what you're gonna be using. Yeah. Then you're gonna come back with them Monday, ne? Okay. Pretty great. Yo. Pretty great, like. So we missed a water break or something. Yes. Okay, check it. Oh, this is also paper too. I wanted for you to look at this.